Good afternoon and welcome everybody. Uh, I'm gonna do a video here for you. It's like third period right now. I'm gonna use this free period to actually get this done. Here we go. All right, we're gonna be doing models, linear models, exponential models, quadratic models. And I think it's important to understand what each model looks like. So, from a standard form of a linear function, always looks like y equals mx plus b. An exponential function always looks like y equals ab to the x. And a quadratic function looks like y equals ax squared plus bx plus c. So we're going to come up with models for those to actually model different situations that's going on. I probably can show you a little bit from here what the graphs look like. Linear function, graph is a line. Exponential, it looks like an exponential curve. And a quadratic function looks like a parabola. So what we'll be able to do is pretty much be able to tell what a function looks like only because we want to know what kind of model we should use to get what we need. So say for this graph right here, it says use the graph to tell whether the ordered pairs represent a linear function, exponential function, or quadratic function. I'm going to do the first one for you. You have, if I plot those points there, say for example the first point that I plot is negative 4, 1/32. So let's say negative 4, 1/32, somewhere down there, it's something very, very small. Right? Negative 2, 1/8. Let's just say somewhere down there. 0, 1/2. What else we got? 2, 2. And 4, 8. You have 4, 8 up here. Now, based on the examples that I just showed you, which one of these does this look like? Matter of fact, I will do this. Give me 1 second. Now, as you can see from the little chart, that these points pretty much model, or they form a little bit of an exponential curve. So pretty much that's what these points follow. You would think that those points are part of an exponential function of sorts, right? I have this one plotted for you, and you guys see from here that looking at these points right here, it looks like a linear function to me. So with that being a linear function, and so, well, actually, let me go back here and actually label these. This looks like this follows an exponential function. And this follows a linear function. And this one right here, when you're looking at it, follows a quadratic function. Right? Another example would be using this graph right here to tell whether it represents a linear function, exponential function, or quadratic function. Now I plotted the points already. And as you can see, with the points plotted, it kind of follows like a parabola in a way. So if it follows a parabola in a way, you know that this thing right here follows a quadratic function. Now, just for a little bit of exercise, you guys could actually get a little bit on your own, get a little bit of work on your own, see if in fact you guys can figure this out. It says tell whether the ordered pairs represent the linear, exponential, quadratic function. Plot those two things and tell me whether or not, you can pause the video and plot those and tell me whether or not each of these sets right here represent a linear function, exponential function, or quadratic function. So go ahead, pause the video and see what you get. Now, if you pause the video, you would have seen that the one on the left represents a linear function. The one on the right represents a quadratic function. So you have examples for each one of them so you can see. Now, graphically, that's an easy part to do. If you were doing this algebraically just by looking at the chart, that's not a problem either. If you look at the difference in ratios of the actual outputs, in other words, the y values, you can tell as well. For example, with linear functions, say you have this chart right here, right? If you have this chart, if the difference in output values, for example, the difference between 2 and 5 is 3, difference between 5 and 8, 3, 8 and 11, 3. If you have a consistent difference in between your output values, chances are you have a linear function. Why? Because it's the same thing. Notice that your y keeps on increasing by 3. In other words, going up 3 as x goes over 1. And isn't your slope equal to the change in y over the change in x? And in this case, the change in y is 3, change in x is 1, slope is 3. You're dealing with a linear function. For an exponential function, it's not the difference between the two, but if the ratio between the outputs is consistent, is the same, then you're dealing with an exponential function. In other words, notice that from here it's going from 0.25 to 0.5 to 1 to 2. If you take 0.5 divided by 0.25, you get 2. 1 divided by 0.5, 2. 2 divided by 1, 2. If in fact the ratio between the output values is the same, you're dealing with an exponential function. Quadratic functions, you might have to do it twice. For a given quadratic function, now keep in mind the first time you try to find the difference between the ratios, say between 5 and 2, you get negative 3. So because 2 minus 5. 1 minus 2, negative 1. 2 minus 1, 1. 5 minus 2, 3. Notice it's all different. However, if you take the second difference, those two, notice that the difference between negative 3 and negative 1, 2. Negative 1 and 1, 2. 1 and 3, 2. So ultimately, you would have to find the first and second ratio. Difference to actually see. Let me give you an example. Say, for example, you have this problem. Use the difference or ratio to tell whether the table of value represents a linear function, exponential function, or quadratic function, and then extend the table to find the y values for the next x value. We'll do that in a second. Let's actually just find out what kind of function we're dealing with. If we have here, the difference between here and here, from negative 6 to 6, is pretty much 0, right? The difference between here and here, right, is 2. Difference between here and here, 4. And then the difference between here and here is 6. So obviously it's not the first difference, so it's not linear, right? All right, let's check to see if it's quadratic. In between here, 2. In between here, 2. Looks like in between here, 2. Notice the difference is the same, right? I should say difference. Just to be clear, second difference is the same. So that means that this is a quadratic function. Boom, quadratic function. Then it says extend the table to find the next y value, well, the y value for the next x value. So say if I did extend the table, say if now I want to find out what's coming next. Obviously my next y value, if I'm going in order, negative 2, negative 1, 0, 1, 2, this is going to be 3. If that's the case, I need to know what's going to be here. So in other words, I want to know here, pretty much. I know that the difference here is going to have to be 2 because it's quadratic, right? So in order for that second difference to be 2, this needs to be 8, right? So notice on each side, from -6 to 6, I added 0. From -6 to -4, I added 2. -4 to 0, added 4. From 0 to 6, I added 6. And now from 6 to 8, I need to add 8, right? So really, this is going to be 14. And it might not make sense the first time around, but we'll get some practice with this. Here's another one. Say here, if you have this function right here, let's check to see what this is. Obviously, I can't tell from there, but let's actually see. Okay, so the difference between these two right here, I'm going to say is 3, right? Here, 3. Here, 3. Here, 3. I think this is linear. This is a linear function. Again, remember the rules that we had were up here. If you're linear, that means all your first differences are the same. Quadratic, all your second differences are the same. And if exponential, that means your ratios between the output values are the same. Here we know this is a linear function. So let's find out what this is going to be. Let's find out what it's going to be as I'm going. You know that if I'm going to order x, -2, -1, 0, 1, 2, this has to be 3. And my difference between them, pretty much 3. Notice that I keep on adding 3. -2 plus 1, I'm -2 plus 3, 1, plus 3, 4, plus 3, 7, plus 3, 10. That means this is 13. Right? And let me do this one for you. Well, actually, nope, let's do this one. See what's going to happen. First, let me check my difference, see what happens. Difference between these two. That's an interesting difference. I'm going to say is what, 0.32? Right? Difference here is going to be 0.6. Here is just going to be 8. No, not 0.6, but 1.6. So then we check these differences. It's not linear. Check those differences. If I check those differences, obviously this difference and that difference is not going to be the same. 8 minus 1.6 and 1.6 minus 0.32 is not going to be the same. So you know it's not linear or quadratic. So let's check to see if it's exponential. That's really much checking the ratios. In between those two, you're talking about 0.4 divided by 0.08. Wait, let's check what that is. 0.4 divided by 0.08. Enter. 5. The ratio is equal to 5. Then from here to here, you want to do 2 divided by 0.4. Find out what that is. 2 divided by 0.4. Hey, that's 5. It might be quadratic. I'm sorry, it might be exponential. If in fact this ratio is the same. 10 divided by 2 equals 5. So this is an exponential function. So take some time and look and understand what we did to get a linear function, quadratic function, an exponential function. Right? And then from here, how about you do this problem right here? This problem right here. Oh, actually, I'm sorry. We didn't get what the next value was going to be. So let's find out what the next value is going to be. Next value, -1. I know that's going to be a 2 right here. If we got to find out, that means that whatever it is, right? Whatever it is, the ratio, whatever it is divided by 10 has to give us 5. So the next value I have, let me take this, shrink it up a little bit. I need to shrink this up a little bit. It goes over here. Shrink this up a little bit. Goes right here. Shrink this up a little bit. It goes over here. Now, whatever this is, whatever it is, divided by 10 has to give me 5. And it's only one number that does that. It must be 50. So you can do the same thing with this one to see if you end up with the... Well, actually, I want you to write the equation for this one. We can do that. If I wanted to tell which one it represents, we can actually write the equation for this. And here's how we're actually doing this. First off, we need to find out what kind of function this is going to be. Let's see what the difference is. The difference here between 2 and 0.5 is not going to be, okay, difference between those two is what, 1.5? Negative 1.5? Difference between here is negative 0.5, right? The difference between here is 0.5, and the difference between these two is 1.5. Now, that is not linear, but if we go here, the difference between those two, 1. Between those two, 1. Between those two, 1. So this must be quadratic. This is definitely quadratic. This is a quadratic function. In other words, if it's a quadratic function, it has the form y equals ax squared plus bx plus c. So if it has that, there's a couple of things we know already here. First off, not only do we know the vertex, we also know the y-intercept. So either you can put it in that form if you want to, or you can put it in the form y equals a times x minus h squared plus k. Since you know what the vertex is already, I think that will be a little easier. The reason why is because y equals a times x minus 0 squared plus 0, right? So y equals ax squared. We just got to find out what a is. I can do that by just plugging in another point. I got 2, 2 over here, right? So why not just do 2 equals a times 2 squared. Take this time out of here. Which is 2 equals a times 4. Divide 4 on both sides. A has to equal 1/2. So that means that the function is going to be y equals 1/2 x squared. So we see ways that we can actually find out what the function is just by looking at the actual chart. So how about this? Why don't you pause the video again, and I just want you to do these two on your own. Just pause the video, and I'll have them worked out for you when you actually get back. So pause the video and go ahead and do those. As you can see, the first one was linear, second one was quadratic. Alright, so that's the end. We'll do the rest in class. I hope you got some benefit from this. And I didn't even hit 20 minutes.